Welcome to today's webinar. My name is Carla Lauder. I'm the editor for SPAR 3D, and I want to thank Supper and Supper for their support of today's webinar, which is how to use AI to unlock the potential of your 3D point clouds, and it will include 3 industry examples. Just a couple of housekeeping notes to go over before we get started, so bear with me for just a couple seconds while we go over these. If you have any technical questions or issues using this webinar platform, there is a chat box that is located to the right of your screen that you can use to contact us, and we can respond right away. If you have issues with your audio that continue throughout the webinar, you can click on a phone icon to join via your telephone, and you'll be automatically muted if you do so, just to make sure there's no background noise for our presenters. However, we do want this webinar to be interactive. And even though we can't hear you, we can get questions from you. So there is a question and answer or Q&A box on the right-hand side of the screen as well. And if you have questions for our presenters, you can put them in there, and they'll either be answered throughout, or we will ask them out loud at the end. There are 2 boxes there. Again, the chat is for the technical problems, and any Q&A can go in that Q&A box, and that just makes sure the right people see those. If you happen to get disconnected at any point during this webinar, you are allowed to log right back on again using those same instructions you got via email. And if you continue to experience difficulty, you can email info@spar3d.com and we'll respond right away. This webinar is being recorded, and you will receive a thank you email with that on-demand version of it within 3 business days. So if you want to watch it again, or if you've missed a portion of it, you can rewatch that. And with that said, we're going to I'm not going to take up any more of your time, and I'm going to turn it over to Sid Heinrich, who is the head of consulting at Supper and Supper, to kick us off.
Carla, thank you for the introduction, and welcome everyone again from my side, and thanks for making it to the webinar. I'm going to share my presentation now.
All right, looks great.
Okay, thank you. And now let's get into it. Okay, check this. All right. Okay, so today I will talk about how we can, or how we as a company leverage the potential of 3D point clouds with the help of AI. And we brought 3 industry examples from our previous projects. By the way, in the comments or in the questions, leave everything you want to know in addition. And I think in the end we will have some time to go into details. And Francie, my colleague, is also here. You cannot see her right now, but she will answer some questions as well. So now let's go to the agenda. So in the beginning, I will have a short introduction about Pointly, what that is, and how we use AI in combination with point clouds. And after that, we will go directly into the previous projects we conducted, and I will show you some real-world examples how we used deep learning, machine learning on point clouds to get information directly from the raw point clouds. In the end, I also brought some more information about how you can leverage the potential of point clouds by yourself together with Pointly. And there is some interesting program or opportunities I want to introduce to you, but more about that later. For the beginning, Supper and Supper is my company, and we are in general a data science service provider and consulting company. We do many different things, everything related to data science and machine learning. And we have a special unit or team for Geo AI. And Pointly is the Supper and Supper brand that is like the umbrella for everything related to point clouds and the services we offer for that. And also we have a platform which is also called Pointly. I will tell you a little bit more about that in a second. So basically Pointly is 2 things. On the one hand, the platform, software as a service solution that is completely web-based, and it can be used for manual classification of point clouds And this is like the MVP that is live already, and it's not supposed to stay manual at all for the future. We are working on more and more automation for that platform and more tools to automate things regarding to point clouds. And we as a consulting company, we are also offering Pointly services, which are of course connected to our platform. So we're doing all kinds of analytics and automation projects for different processes, including of course all the AI solutions that we are developing. Some more examples to come. So this is like a very, very short GIF about how Pointly looks like. So the web platform, on the upload of any point cloud, there will be a pre-processing that's like segments the point cloud into homogeneous areas. And with the help of those, a point cloud can be classified very fast. So this is really independent of point cloud type. So any kind of point cloud can be uploaded to Pointly, and we can classify any object we would like to. So we are not bound to any standard class, but we can create our own labeling catalog. And I think you will also get this presentation later. There's a demo on YouTube. It's linked here. If you're interested in that, you can watch it. But that's not what I want to be talking about today. I want to go one step further and tell you why we need those classified point clouds. And some of you might have guessed it. We need them as training data for our deep learning models. Because to automate the classification, we need training data and samples of classified point clouds to train custom neural networks and custom models to do this in an automated way in the future. And this is well needed for use cases where we have very large areas or a lot of different scan sites, or when we have recurring scans, so like scans every month or maybe every year or even daily. And for cases like that, a manual classification or a rule-based classification is nothing that is really scalable or adaptable. And this is where deep learning can help a lot to make those use cases become possible. And from the classified point cloud on, we have lots of opportunities to do further analysis, which I will also show in the example project. So let's jump right into that. So the first industry example is from the sector of mining. The customer here we work together with is RAG. This is a company that monitors former coal mines in Germany. So they have yearly updated LiDAR scans, and the main goal is to do risk assessment for large areas where the coal mines were, to see if there is any change in the landscape or in the surface. And for that, they need really precise digital elevation models. And there are a few more cases that I will show in a bit. So what we did for this customer in the first step is we uploaded some of the data to Pointly and generated training data to have an automatic classification later on. So this is a sample of the training data we created in Pointly. We not only have ground and vegetation buildings, but also like power lines and power poles and vehicles, for example. So even if this was a proof of concept or a start of a project, so the very first project phase, we already generated very precise training data that covered even more than the initial scope of generating precise digital elevation models and mapping the vegetation as well. And from the training data that we got, we trained the neural network. And this right now is an actual output of this neural network. So this is something that we can generate again and again without touching any rules or having any fine-tuning here. this can now be generated every year, and we also already did this for several years. It's not a perfect prediction right now, so especially for the power lines, there are some misclassifications for now, but this was not the primary goal of this project. We had very few samples of power lines in the areas we got for now, and this to be improved in the future, of course, because we will have more project phases and generate more training data to optimize this network even more. And this is what we did with that data. We could create very precise digital elevation models and do some change detection between the years. And like this, we can see like different areas where changes happened, and those can be now analyzed further with also high resolution satellite images or with people being there. And, this is like a huge step forward, because in previous data there were many false positives through not precise enough DEMs, and now this is already a step forward, and we can even improve this quality in the future. Like a nice bonus or side effects are we can do the same for buildings, for example. Same here. This is not a very perfect prediction. We see that there are some false positives on the right, but we also find new buildings if we like set some thresholds, or in the future when this detection will be more precise, this will also have variable outcomes. But this is not something we need for this project. It's just something we can show because it's there without additional effort. Same for vegetation change detection. This is also not something we needed to do, but it's already there. And for other projects with a focus on that, we can reuse those approaches and do the same. What we indeed did for RAC was a tree inventory. So on the next slide, so we took it one step further. After we extracted the vegetation on the top left images, or the left images here, we did some further analysis and created some algorithms to separate the single trees. So in this case, we used a combination of top-down and bottom-up approaches to distinguish where one tree would end and another begins. And this even works for very dense forest areas. And for this customer, we were able to create a GIS layer with like tree shapes and an estimated stem position. Okay, jumping to the second use case. This was another project that is still ongoing. It's an infrastructure project where we assess German highways, or Autobahn here. And it was about very high resolution mobile LiDAR scans. And the goal in the end is to get a precise CAD model. And the goal that we want to achieve looks like that. So this is the result that this is not a result of our algorithm yet, but something that very specialized persons draw by hand at the moment. And this is not a matter of hours, but rather weeks or months to create this for a few kilometers of highway. And in Germany, we have several thousand kilometers of highway. So this is not something that can be done for a whole country or even larger areas. So our goal was to automate this process. And we have different approaches for that. On the one hand, we went the same way as we did for RAC. First step is to create training data and have a classification. So we have an adapted segmentation. So this is how it looks in Pointly before we label it. And on the right side, we see some training data that we use to train neural network again. And from the classified point cloud, we can then separate like the highway from the road markings and rails and bridges, and also derive a CAD model from that. Here we see some more examples how it looks in Pointly. So on the right, this is an output of training data. We have many classes here. I think it's almost 10 different classes that were classified manually. So this was a very cumbersome piece of work. We did this for about 600 meters of highway, which is not a lot for training data, but was sufficient to prove that our model will learn on that, and it already delivers pretty decent results, which I will show on the next slide. So here's like a small comparison of labeling work. So the ground truth top left that we manually did, and top right, this is the model inference that was created. And this is some of the test data. So our model hasn't seen this exact scene here before. And on the bottom right, we see the data. So it's not a very perfect prediction right now, but we see the scene in general is understood. So those results are very promising, and we will optimize this further to get a higher precision, because right now there are a few inaccuracies left where the classes transition. But from that, we can already derive simple vector lines with some tricks. And another thing we are already working on in parallel is what we codenamed the graph learning POC, where we try to derive the CAD models directly from the point cloud. So we are in this proof of concept skipping the step of classifying the point cloud. Here we are using the point cloud and the vector lines as input for the neural network to learn on, and predict points on the point cloud where certain vector lines should be. And for this we use the point cloud like a graph, where every neighboring point is connected to each other, and we train the network to learn where certain lines will be. And what we see here is not a real point cloud. This is like synthetic data, where we tested our pipeline on and developed the approach. And this is right now transferred to real world data. And we already have results that are working. And we are currently generating more training data for that. But as I said, there are many companies specialized on drawing those lines by hand. So there's a lot of ground truth and training data to leverage to automate this project. And the third use case, I will keep this one short. It's about city planning and deriving 3D city models, like on the bottom right. This was a prototype we built for a public tender for a city. And footprints of buildings were available and 3D point clouds. So the goal was to derive a roof structure of the point from the point cloud, and we did this by first classifying the point cloud again into roofs, separating them from the ground and other things, and then extracting the surface and key points from that to generate simplified roof models. Sadly, we didn't we didn't want this tender because a manual or a company who does this manual was cheaper. So a workforce will do that by hand now. And that's a little sad because that's not a sustainable approach, because with the development of an automated approach, we would have higher costs once, but this could be applied and scaled to other cities and further use cases, of course. We also have a prototype for generating CAD models of roofs. So complex roof scenes can also be saved in a 3D format. And now let me quickly introduce you how you could make use of Pointly and get into automation with point clouds. Because we have a special program right now where we are introducing new functionalities to Pointly, and it's like a 4-steps approach for to get started with that. First, if you already have data and like larger areas of homogeneous point clouds, those can be uploaded to Pointly. So just to our web interface, and from there on, training data can be generated. So Pointly is usable by everyone, but we also have a workforce in the background who can generate the training data for you. And from this training data or classified point clouds, we can train a very custom model for just for a certain use case. So there will not be one model that works for every point cloud out there, that's for sure. So that's why we want to do it for specific customers or specific use cases indeed. And once the model is there, we can offer a classification service. So every new point cloud that is uploaded can be classified automatically. And for a normal proof of concept, for step 2, we plan like 5 to 15 days of effort for labeling, which is not a lot, but can already deliver pretty decent results. And with the help of Pointly and the tools that we have there, the results can easily be corrected or even enhanced. And we can use this enhanced or correct data again as training data to further optimize the model. So, of course, in the future, we want to implement this as a full process in Pointly and the self-service process. But for now, yeah, we like having in beta, and everybody can be a beta tester. So if you're interested in that and you have data already, I think Francie can post we have a little form that Francie posts in the chat right now. And if you get the PowerPoint, there will also be a link here. So we would be happy to get in contact and see if you can get a free custom model for yourself. So for this beta, we would charge no costs for Pointly or for the model training. Okay, now here I have some of our contact details, so don't hesitate to contact any of us if you have a specific use case in mind or have some more questions or want to get in touch to talk about projects or things you are working on. And for now, I want to thank you for listening to me, and I guess we can come to some questions now.
Sure. So thank you, Sid. There's a lot of questions being answered in the chat. What I'm going to do is I'll ask a couple of the ones that are sort of a little bit broader for you guys, and then we can continue to kind of follow up with those in the last couple minutes that we have here. So one of them is, how long does a workflow typically take to do a change detection type project?
Okay, so for a change detection, the most effort for that is now to generate the training data, to be honest, because we have pipelines in place to train a neural network. This takes compute time, but as we normally leverage the cloud for that, it's neglectable. But training data needs to be generated, and the change detection, it depends if it's a one-time analysis or if there is a need for a web app or something like that. But we can think of anything between a month and 3 months maybe for a project like that.
And is the catalog panel hard-coded or something that the user can set their own fields for?
Oh yeah, that's a very good point, because one of the major advantages is that it's not hard-coded. So any class can be created there, and you can even create custom catalogs for different scenarios. So, for example, I have one for street scenes or one for forest scenes, and based on the catalog, a model can be trained. So this is something we like to combine. And we are also honoring the standards. So we are working with the less IDs there for the standard classes, and the other range for more classes can be used to just create custom IDs, and also the colors are adaptable to anyone.
And then could you use this on a bathymetric point cloud, in other words, to teach it to detect underwater objects like containers, blocks, or rocks?
Yeah, we had some requests for that, and also tested some data in Pointly. So the main thing right now or requirement is the LAS format. That's the only thing that is accepted to upload to Pointly, but almost any point cloud can be converted to that. And once it is in Pointly and we can see the objects and to generate training data and label them precisely, there can also be a trained model in the end.
Could it be used to detect indoor pipes or conduit?
Yeah, so basically it always depends on the quality of the scan. But like as a thumb rule, everything that we as a human can see or distinguish can also be learned to be distinguished by a machine. So maybe if there are like 3 pipes that look the same but can only be differentiated by knowing what is inside them, the machine cannot learn it. But if they look different or if they have different colors or something like that, then they can be detected as well.
And how much training time is usually needed to teach the machine learning engine?
That really depends on how much you invest. So this is a process that can be highly parallelized, and as we do it in the cloud, you could use several GPU machines or some high performance cluster to do that. But normally, like a good approach that we use for ourselves takes maybe 4 days running on a very few machines.
Great, and I think we'll have this be the last question before we wrap up, which is what methods or metrics can you use to validate the manually generated annotation and labels?
To validate the manual annotations, this needs to be a manual process. There can be different scenarios for that, like a few persons labeling the same point cloud and checking the differences. But the ground truth is only as good as the labeler. So we need to make sure that the labeling catalog is very well defined and have rather manual checks of the data to make sure that the data quality is good enough.
Great. All right, so I know there's a lot more questions in the chat, but we are going to send this chat transcript over to Sid and Francie so we can follow up with you after the fact if you have a more specific question. So thanks everyone for your awesome questions today. And just a couple of things before we close. I want to thank Sid for joining us today. Thanks Supper and Pointly for their support of today's event. And a couple of questions that I did see in the chat is, yes, this webinar is recorded, so if you joined late or if you just want to watch it again, you'll get an email, and you don't have to do anything, but you're going to get an email automatically with a link to an on-demand version of this presentation. It'll also include a copy of the presentation that you saw here, so the links that Sid were talking about will also be available for you to check out. You can take a closer look at some of those cool point clouds. And then we're always eager to receive your feedback. So when you actually close or when this WebEx window closes, a teeny little survey is going to pop up. If you take a couple of seconds to fill that out, we would appreciate it because we always want to make these events better, and we do read your comments in there. Thanks again to Sid, and if you want to contact me directly, my email is clauder@divcom.com. But thank you to everyone taking the time to attend this webinar and for all the great questions. Hope you have a great rest of your day. Thanks so much.
Yeah. Thank you. Have a great day.